This is Saurabh with Ankur, and in this movie, we are going to talk about Internet of Things for Smart City, which is also called as Urban Internet of Things. We will discuss about smart city and the benefits they bring to our society and the challenges in implementing this futuristic concept. Our main focus throughout this movie will be to discuss the Internet of Things architecture for a smart city. Okay, what is Internet of Things? The Internet of Things is an environment in which objects, animals, or people are provided with unique identifiers and the ability to transfer data over a network without requiring human to human or human to computer interaction. Now, the data accumulated in the cloud in humongous amounts can be used to provide services across different domains, such as consumer and home, where smart homes with various functionalities can be built. It can be used to provide security services such as video based security, circuit monitoring, and video analytics. It can be used in creating a smart infrastructure, providing services such as smart parking, energy monitoring, waste management, etc. It can be used in the healthcare domain to provide better healthcare services. It can be used in the transportation domain for traffic and transportation monitoring, and many other domains. Some statistics of IoT. According to a survey by Gartner, the number of connected things stand at 7 billion in 2014 and are projected to be at 26 billion in 2020. According to a survey by Forbes, the number of connected cars and connected lights are currently at 23 and 2 million respectively, and they are poised to reach a mark of 253 and 100 million respectively. Industries belonging to sectors of IT, finance, retail, manufacturing, and many others are increasingly adopting IoT practices, and the number of connected businesses stand at 1.7 million in 2014 alone. The number of people who are using IoT or plan to use IoT are also growing hugely by the numbers. The IoT market currently stands at 2.3 trillion dollars and is expected to reach at 14.6 trillion dollars. These figures show that IoT is poised for a rapid and exponential growth. What is a smart city? A smart city is an innovative city that uses information and communication technologies and other means to improve the quality of life of its citizen, efficiency of urban operation, services, and competitiveness, while ensuring it meets the needs of present and future generations with respect to economic, social, and environmental aspects. To get a brief idea of a smart city, here is a short and nice description from Cloud Consortium.
About an innovative solution for tomorrow's smart cities. Today, progress in micro and nanotechnologies has considerably reduced the size of communicating devices, such as sensors or smartphones. These can be deployed easily, whether on the scale of a home, a city, a country, the world, or even beyond. Imagine a city filled with various sensors for traffic, pollution, weather, noise. Anything's possible. At each point in time, these devices generate data specific to that city at that moment. Now, imagine that you can retrieve this data flow securely. Imagine that you can store it. Imagine that you can sort this data flow in real time in order to offer it for various applications. These applications could then combine data to make enriched information. This information could be used by various tailored, responsive services designed to improve quality of life for the city's residents. This innovative solution has a name: the Cloud of Things.
This picture shows the various services provided in a smart city. Smart lighting. The optimization of street lighting efficiency is an important feature in a smart city. In particular, this service can optimize the street lamp intensity according to the time of the day, weather condition, and presence of people. Smart parking. Finding a parking spot in a city is a very big problem. Sensors detect whether a parking spot is available or not and transmit this data to the server, which is then communicated to the end user via an app. Smart transportation. Even though camera based traffic monitoring systems are already available and deployed in many cities, low power widespread communication can provide a denser source of information. Traffic monitoring may be realized by using the sensing capabilities and GPS installed on modern vehicles. Smart waste management. Waste management is a primary issue in many cities. Intelligent waste containers, which detect level of load and allow for optimization of the collector truck route, are used for efficient waste management. A smart city also has other features such as structured health services, video surveillance, city services for emergency response, energy management of public buildings, noise monitoring, and air pollution monitoring. Challenges in implementation of smart cities. Under the political dimension, the primary obstacle is the attribution of decision making power to different stakeholders, causing a policy paralysis. A clear business model is lacking, and adverse global economic situation is responsible for general shrinking of investments on public services. Coming to the technical challenges, a general reference framework for designing a smart city is missing, and non-interpretability of heterogeneous technologies currently used in city and urban environments pose an obstacle in implementing a smart city solution. Challenges in IoT. Sensing. Innovative ways to sense and deliver information from the physical world to the cloud remains a challenge. Connectivity. Variety of varied and wireless connectivity standards are required to enable different application needs. Power. Many IoT applications need to run for years over batteries, and reducing the overall energy consumption is a challenge. Security and privacy. Security is vital, and protecting users' privacy, detecting and blocking malicious activity always remains a challenge in IoT. Also, IoT is complex, and IoT application development needs to be easy for all developers and not just limited to experts. Also, different standards for different platforms and services is a severe challenge in IoT.
So let's talk about the architecture of smart city. It has a centralized architecture as seen from the services provided by a smart city. So we have a urban area, and then we have tons of dense and heterogeneous devices deployed all over the urban area. They are sensing data from different sources. Then there are different types of data in which they store the data. And then we have different communication techniques. These devices use one of the technique to send the data to a centralized server or share the data to different devices using these techniques. So then we have the control center, which is our cloud server, where all the data accumulate. And few of the example for the cloud server is Google Cloud and Jasper.
Because of the existing heterogeneous devices, data types, communication techniques, IoT domain is still struggling for a reference architecture which could be used as a standard for any IoT structure. One of the standards provided by IEFT, which is the Internet Engineering Task Force, because it's open and royalty free and based on the best internet practices. It suggests a web services based architecture which is flexible, interoperable, extendable to IoT nodes using REST architectural style. This web services based architectural approach can be used in IoT for smart city.
The protocol stack is an implementation of a computer networking protocol suite. Strictly speaking, this is the definition of the protocols, and the stack is the software implementation of them. Devices in an IoT network is categorized into unconstrained and constrained devices. Both categories have slight differences in their protocol stack depending on their storage and processing capabilities. Important layers of a stack are data layer, application and transport layer, and network layer. For unconstrained devices, the data layer uses HTML or XML format, while and then HTTP and TCP protocol is used in application and transport layer, and IPv4 and IPv6 is used in networking layer. Now, the constrained devices, they use EXI format in the data layer and CoAP over UDP for the application and transport layer, and then IPv6 or 6LoWPAN for the networking layer. This is not always the case, but they mostly use this protocol stack because of their lower processing capabilities. A stack of unconstrained devices is mirrored into a stack of constrained devices with some specification changes. Protocol stack of constrained devices has high complexity at each layer and is supported by any devices. While on the other hand, protocol stack for constrained devices has low complexity and is supported by constrained devices having low CPU processing and low storage. The data layer of unconstrained devices use HTML or XML format to send or receive data. This contains the transferred content and its description in a defined schema. The size of these messages are large, often too large for any IoT devices to process efficiently. So the solution is to send or receive data in EXI format when it comes to low capacity IoT devices. So the data layer of constrained devices uses EXI format for data transmission, which is also W3C proposed. This format natively supports and generates messages in open data format. This is strongly compatible with XML, and databases can be used to integrate XML and ESI data sources. It is very efficient to be used by low capacity devices because of its low complexity and size. Then EXI format defines two types of encoding, which are schemaless and schema informed. Schemaless encoding is directly generated from the XML data, while the schema informed encoding, it is assumed that the end devices are aware of schema before the actual encoding and decoding takes place. Now, if we talk about application and transport layer in unconstrained devices, most of the traffic that crosses internet nowadays is carried at the application layer by HTTP or TCP at transport layer. The verbosity and complexity of native HTTP makes it unsuitable for development on constrained IoT devices. Whereas on the other hand, TCP does not scale well on constrained devices, which yields poor performance for small data flowing in lossy environment. The solution for this is proposed to be CoAP protocol at application layer over UDP protocol at transport layer. So the CoAP and UDP protocols are the alternatives for HTTP and TCP protocol at application and transport layer for the constrained devices. The CoAP protocol overcomes these difficulties by proposing a binary format transported over UDP, which is a lightweight transport layer protocol, and they handle only the retransmissions strictly required to provide reliable service. Moreover, CoAP can easily interoperate with HTTP because it supports the REST methods of HTTP like get, put, and post, and there is a one-to-one correspondence between the response codes of the two protocols. Internet hosts can natively support CoAP to directly talk to IoT devices. The most general and easily interoperable solution requires the development of an HTTP CoAP intermediary, also known as cross proxy, that can straightforwardly translate requests and responses between the two protocols. Next, we have a very important layer in our protocol stack, which is the network layer. IPv4 is the leading addressing technology for unconstrained devices, whereas IANA, an international organization, has announced that IPv4 addressing blocks are exhausted due to high number of devices already. A solution to address huge number of IoT devices and other devices is given by IPv6 standard. This provides 128-bit addressing field. This resolves addressing issue, but the issue is that the overhead provided by IPv6 is not compatible with constrained devices. And a solution for this is to use 6 low pan technology at network layer, which is required for limited processing capability devices. The issue with the constrained devices using IPv6 is overcome by using 6 low pan technology. This establishes compression format for the IPv6 headers over low power constrained networks. There is an easy conversion between IPv6 to 6 low pan, while the problem remains with the conversion of IPv6 to IPv4. But there are methods for this conversion, which are V4 V6 port address translation. In this method, we map arbitrary pair of IPv4 addresses into IPv6 addresses. And the next method is V4 V6 domain name conversion. This method is similar to the technique used to provide virtual hosting using HTTP. Similarly, it is possible to program the DNS server in such a way that it will take care of the conversion from IPv4 to IPv6. And then the next method is URI mapping. This technique involves a particular type of HTTP CoAP cross proxy. An IPv4 to IPv6 conversion is internally resolved by the applied URI mapping function. This is the standard architecture, which is web services based, and this can be used as a reference architecture for the smart city IoT. This diagram gives a brief overview of the devices and the corresponding protocol stack which they are compatible with. At the root of the system is the control center. which is also called as the cloud server. The devices in the control center have high processing and storage capabilities. Thus, they use the protocol stack for unconstrained devices as explained earlier. This cloud center has devices like database manager, backend servers, web frontend, etc. Then the next level of this system is the gateway providers like router. The devices at this level are edge devices, and these devices provide protocol translation and functional mapping between unconstrained protocols and their constrained counterparts. At the leaf level is the peripheral nodes, also called as the IoT nodes. These nodes are the devices which produce data using sensors and actuators, etc. These nodes are connected to IoT peripheral clouds. These devices and peripheral clouds have limited processing and storage capabilities. Thus, the devices may use the protocol stack proposed for constrained devices.
To conclude, we saw a general overview of Internet of Things. Then we explained smart city in terms of its benefits, challenges in its implementation, and a standard architecture framework for IoT for smart city. Thank you for patiently listening. Hope you enjoyed the movie.